Thank you, Matt. I hope you can hear me okay. Thank you for being here today. It is honestly an honor and a bit scary to be here and speak for the first time in front of such an amazing audience. For those who do not know me, my name is Haneen. I've been a Wi-Fi evangelist for as long as I can remember. I moved all the way from Jordan to the UK to pursue a wireless consultation career. I currently work as a wireless subject matter expert for Orange Business. And more recently, I received my CWNE number, 621. Thank you. Which I still cannot shut up about it. For today's session, it is going to be my own personal journey for adopting 6 gigahertz in the real world. I promise it's not another theory talk or another checklist. It is real and raw, and I hope at least part of it would resonate with some of you in this room. I will tell it in a form of 3 acts so we can breathe in between. So why did I try 6 gigahertz? It's been around for years. It's no longer the shiny new band anymore. And like a lot of you, I've been quietly listening to other people's experiences, waiting for the right moment. And it came, and the trigger was pretty much operational. For one of my customers, we noticed high increased volume of performance incidents affecting the noisy, painful users, VIPs, CEOs, CTOs, and they were always affecting those people whenever there is a high visibility event. Those kind of incidents kept everyone on edge. So the question kept coming, can we reduce this operational stress through this shiny 6 gigahertz band, considering that we already have the capable infrastructure, hardware, and clients? So when I proposed the technical adoption, the response was, we need to prove it responsibly. We cannot roll it everywhere. And before I show you what happened later, I would like to walk you through the process of where did we decided to enable this in the first place, and that's where Act 1 starts. Act 1 is all about the screening phase. It's where we separate capable from deployable, and if we done Wi-Fi long enough, you would know that those are not the same thing. So, context on scale first, this client had a large footprint. Across all 3 regions, we had nearly 1,000 sites, and with such a scale, the last or the worst thing you can do is picking a site based on convenience. So I needed an elimination process, 2 lenses. The first one is by help of Cisco Catalyst Center, the 6 gigahertz readiness dashboard that just gives you a very basic level of the prerequisites, like are the AP model right? Do we have enough capable clients? Doesn't tell you the whole story, of course, but at least it gives you a very high level of the building blocks if they are there. Now, with the help of that lens, as you can see, I eliminated one whole region, ABAC. It came with the lowest number of APs and clients as opposed to the other regions. We got America, with good number of clients and APs capable of 6 gigahertz. We got EMEA, kind of similar number. So they are very close, so I needed a further elimination process, and that's where the second lens come to the rescue. So the second lens is just scorecard weighted model that I generated that is consisting of 2 layers. The first one is the hard gate, which is simply the prerequisites, the non-negotiable ones. If we fail one, we basically stop. This side is discarded. Now, the other layer is a bit more tricky. It's all about maturity and risk. It's a mix and match of operational and technical requirements. It's how and where we can deploy 6 gigahertz that would add value, but it wouldn't introduce risk. Now, the exact score and weight I can share later, but I don't have much time. So that model helped me eliminating another region, which is EMEA. Not because it was weak, as you saw, it really showed good numbers as opposed to America, but because I wanted some flexibility with the channel inventory so I can test with the higher throughput and wider channel width, which unfortunately, EMEA doesn't give you this option because it only allows the lower band of the spectrum. Now, with EMEA being discarded, I got my first reality check, which is deployability or readiness on paper doesn't mean that it is necessarily interesting to the business. So for EMEA, for example, it showed it's ready on paper, but unfortunately, business don't really buy spectrum, they buy outcomes. They buy less operational pain, reduced VIP incidents, and tangible outcomes they can measure and trust. And with 6 gigahertz, we all know that the cost isn't just switching it on. It comes with extra costs like adding more APs, extra out of work, and client interoperability. So when you start your own POC, you need to think, I learned this the hard way, where and how 6 gigahertz is there to add value and where it could be actually introducing risk. Now that I'm left with the Americas, I applied the same model, and the large final site ended up being a manufacturer and building office site in the United States, which checked all the boxes: high operational visibility, high business priority, and most importantly, the largest concentration of the client count of the 6 gigahertz capable ones were located in this exact site. Also, it showed really good numbers of capable ABs and clients. With that, I realized my second reality check is that across all 3 regions and almost 1,000 sites, when I applied this model, only 100 or maybe less of sites showed the readiness to apply 6 gigahertz without creating friction. And of course, you may argue that your own selection criteria might be different, more forgiving, but you'd still be surprised how fewer sites would really show the readiness to add value without really causing any pain. And with that, we move to the second phase, or act, which is the WLAN and RF engineering hygiene phase, the part we tend to enjoy the most. Now, because this is an existing infrastructure, I anchored my RF planning around the existing 5 gigahertz design with minus 67 dB at the edge. And I only plan to use the 20 megahertz channel width initially, where those wider widths will be introduced later on. The RF characteristic wasn't really that much out of the ordinary. It's just an office, typical one, drywalls, ceiling tiles, pretty much predictable. Some of the areas had metal doors where I expected that they could maybe cause local shadowing, where the problematic area for me was the areas with tinted glass, where I expected that those might be a bit risky to cause some absorption at the cell edge. Now, to answer the most urgent customer question and the accounting team, whether we need extra APs or not, I relied on the power level distribution as an indication for cell size and capacity. And lucky me, most of the APs ended up being concentrated in the mid-range. So that was an assumption a 1-to-1 6 gigahertz overlay is feasible for the site with, of course, respect to the 3 dB compensation rule of thumb. Now, another reality check around the RF planning is that it is as good as your own source of truth. Unfortunately, for me, this site never had any previous site survey. And when I asked for one, they just replied saying, it's a BOC. We cannot really justify the fund for it. And this is a constraint that you might need to be prepared for it. Hopefully not, but you might need to just work around it. So for me, I relied on the predictive planning and the RF intelligence I collected, and I meant to keep the scope really controlled. Now, the target areas were, as I mentioned, were very selective. It is meant to be only targeting a single floor, where areas reflecting the user experience. I really don't care about manufactural areas, so I excluded everything that wouldn't really reflect a practical and something the client would really relate to. So offices, meeting rooms, collaboration areas, anything else isn't really important. And we pushed the configurations only to the APs that cover those areas, which got the customer on board, because no one roll it out everywhere. And the last piece of the design, and honestly, this was the easiest part of the whole BOC, because the customer existing corporate SSID was already running WBA2 and WBA3 with PMF required, not even optional, which was such a huge relief to me, because that meant I'm not enforcing a new security posture for you guys. And we reused the same authentication model, EPTLS, same access policies, maybe extra authentication and authorization policy on the AAA server. That was pretty easy. Now, for the target use cases, as I mentioned, I really wanted to show the added value. So they were meant to be targeting only those painful users, VIP, CTOs, CIOs, whoever complaining about the Wi-Fi and make our life miserable. And whenever there is a high visibility event taking place on that site, we enable this SSID. So it was very selective. Now, for the validation focus, I really wanted to have it focused on the discovery reliability and join authentication, roaming stability under the security posture. Wasn't really interested to jump right away at the throughput testing, because only when those two are solid, I can really move to the throughput conversation. And that's pretty much the setup. And we move now to the third act, where the story gets more interesting and it shifts. Now, if I'm being honest with you, I think we've taken network discovery for granted for years, where previously with the legacy bands, it just worked well enough, where we focused our energy elsewhere. Even when I used to work in Cisco TAC, it wasn't really one of the top 10 issues in my backlog. Now, fast forward to 6 gigahertz, it does change that, because the discovery path is no longer as forgiving. And I realized that discovery isn't really a single moment, it is a sequence of events. Now, you may argue that discovery isn't that much important, but for me, it really mattered to prove a reliable one for this POC, because it's like the first impression you make for the customer and the clients using it. And if it didn't really work, nothing else about 6 gigahertz would really matter. Now, the first discovery challenge I faced is that, okay, we got it right now. The first one, ironically, that it never happened. And the main trigger for it was the use of a hidden SSID on a 6 gigahertz only network. And I know, before you judge me, 6 gigahertz only on a hidden SSID and hidden SSIDs in general is never a good idea for any radio. It adds zero security. We all know that. But for this POC, the customer requested it just to keep the operational noise low and avoid any uncalled for service desk tickets. So I had to accept it to keep the friction low. And what I noticed is that for Samsung and Apple devices, the mobile ones never really discovered the network. And for Google Pixel and MacBook Pro 3, they could discover it, but it was delayed. It didn't happen right away. We had to toggle the Wi-Fi a couple times. And for this site in specific, we had the majority of population HP Elite laptops with the AX210 and 11 Intel laptops, adapters. Shout out to Cisco BC Analytics feature, by the way, the zero-touch one that can tell you the adapter just by enabling the device classification feature. Now, anyway, I learned for the first time, because the population is the majority Intel, that there is this behavior called no initial radiation that is specific to Intel. And in basic terms, that means the Intel device may not initiate the transmission on that 6 gigahertz network until it hears the clues about it. So when you combine this no initial radiation with the hidden SSID on 6 gigahertz only network, you basically remove all the triggers that are required to locate the network. And this is an exhibit of packet captures I've collected while troubleshooting the issue, where the SSID, as you can see, is missing. All you can see is just a stream of beacons, where, on the other hand, when you just have the SSID visible, the client behavior just flips, and you see the probes in action. So the takeaway, do not enable hidden SSID at all on a 6 gigahertz network at all, or even at all. The second challenge, on the other hand, is a bit different, because discovery could happen, and it will happen, but it becomes more of a scan efficiency problem and predictability. So as you all know, I will go over this very quick, the core mechanic of probing on 6 gigahertz. It's restricted unless you are doing it on a primary scan channel. Even on those channels, there are timing restrictions, scan schedule that is affected by driver-driven logic or vendor decision. Now, with those restrictions, of course, the client would need hints to know about the existence of 6 gigahertz. And when the 6 gigahertz network is there, you need to know about those through for example, if out of band, through the R&R carried in those beacons, or through false or UPPR, which I learned that they are not really, I haven't seen them in action, not really widely adopted as the R&R one. Now, for any reason, by any shape or form, if that hint reach is reduced or impacted, then definitely the discovery efficiency will be degraded. For example, one of the HP laptop had the MT MediaTek 7922 adapter, and I observed that those adapters, they are just the worst. They really deprioritize the scanning of the DFS channels. So whenever the client is only surrounded by APs operating on the DFS channels, the scan efficiency will be really degraded. And back to the site client population, as I mentioned, it is heavily Intel, so the client behavior was kind of consistent at first. But when I introduced more varied clients, because utilizing the bring your own device solution, which is varied by nature, the discovery success rate started to wobble because the behavior is no longer uniform. So I'm trying to say that with BSC and R&R dependency, those hint reach really matters, and if it is impacted, it will definitely affect the scan efficiency. And now with the last challenge, and who is in the room can raise their hands if they've been in a situation where the client start acting crazy out of nowhere. Yeah, been there. It's usually something we have little to no direct control over. The client just start acting random due to some random logic. And of course, it's been the case for all other radio networks or features or protocols out there, nothing exclusive to 6 gigahertz. But it did really matter to me because, maturity and predictability matter a lot, especially for a POC where I'm trying to convince my customer to do a global or at least a state-level rollout decision. So one of the things I observed for MacBook Pro M3 running the Sequoia 1561, whenever the 6E mode is set to auto, it kept juggling between 5 and 6 gigahertz, while other MacBooks not running the same version were not really showing the same behavior. On the other hand, Samsung devices, Ultra and 22, 23 Plus, whenever the mobile data is off, which was a very random by coincidence observation that whenever the mobile data is off, discovery never basically happens. And also the roaming behavior was not very consistent when we first introduced the 6 gigahertz BSS. I think it took it a while to save it in the channel list. Now back to Intel, because it's the one that matters most. When I started the configuration and the SSID introduced, it was configured with WBI3 BSK SAE because it wasn't really, the .1x setup wasn't there. So what I noticed that the AX211 adapter, it really had a hard time and a delayed roaming decision to move, and sometimes you had to do a manual reconnect. While when we moved to the .1x SSID, same behavior, same client, same environment, the roaming behavior got much, much better. So if I have really to wrap up my journey so far, I would say that I really expected the constraint, in my case, to be the spectrum with the different thinking and RF requirements that it demands. But in my case, it was the client interoperability and also me trying to align with the business requirements and needs. So I'm not saying 6 gigahertz is bad. It works brilliantly, but it does really enforce the ecosystem to grow up, and it really exposes the market gap whenever there is a varied ecosystem with different client vendors. So I think my conclusion is that selective enablement is really pragmatic, and that's what really could grab the business attention. Define your use cases and design for discovery reliability, and make sure that the client interoperability is tested heavily. Wait until the ecosystem matures and grows up, then maybe we can hopefully allow for a wider rollout later on. So for my VOC, I just want to say that it is still a work in progress. You know, enterprise times take forever. I will definitely keep you posted. Please keep in touch, reach out to me. I will love to share my experience and hear yours as well. But until then, please keep in touch, and happy refining, everyone. Thank you.